start typing and they don't actually design. So they confuse, or we tend to confuse the framework with the domain. The domain is actually the thing that we're modeling. The thing that is the environment.
Okay, so we were talking about that framework is different than the domain, and sometimes we tend to confuse the domain with the framework. That's the first thing I'm going to expand on. The second thing is going to be a test-first approach. Who here does TDD or test-driven development? Okay, not many. Tests, you write the test-first approach. Basically, you write tests, and then you implement the code for it. Okay, so you describe behavior, and then you implement behavior. The test-first approach, basically, you write the test, but you write it well. So a test well written will help you to implement, and it doesn't have to be correct, but it has to be a well-written test. That means clean code, well-written test. The third thing that I'm going to talk about is basically how your problem solving goes from a domain that you're modeling into another model, an evolution, and the next step of your model of your problem. So your domain improves the modeling. And last, the fourth thing we're going to talk about is the implementations of true details. True details because they are complementary, they are secondary. They are not your core domain, they are not your core problem. And usually what we were talking earlier with Antonio is we say that we're solving problems when we use a framework, but maybe we're not. And this is kind of what I want to hook you up with this idea in this talk about maybe we're doing something wrong. Have you seen this movie, Inception? It's basically about dreaming, deceiving, think that you're dreaming the reality. So have you seen that movie? So what these two movies have in common? They do have in common that they're out of touch with the true world or the real world. In this case, we talk about then deceit, like we think that we've been taught the wrong thing, and we might think this if we find some signs of inception that maybe we're familiar with. We think that our framework is the best. We think our practices, our best, so-called best practices are the best. And we think that our community, the people that write our framework, even ourselves, do not make mistakes. So we think they're perfect, and maybe we go for Symfony, maybe we say Laravel is excellent, and now we're jumping there. Well, a framework might be convenient, but might not be what you are actually looking for. So we're talking about inception, wrong ideas. But in reality, we're paid to solve the problems. We're not paid to use a framework or become experts in a framework. So sometimes I see, like in Twitter or jobs postings, hey, we need a Symfony guy, or hey, we need a Laravel guy, or hey, we need a Scala guy. That is kind of, you know, when I used to think, okay, I would go to Sensio Lab Connects and say, okay, yeah, I'm a senior Symfony developer. Wrong. I got it wrong. But I'm going to try to convince you that, okay, so a couple of days, or well, some days ago, there was this Symfony Lab presentation in London. My friend Marco Da Bertoli was presenting, and he made an interesting point. He had talked with the client, or he was making this illustration between the client and the developer team or the company that does their work for them. And basically, he was working with Magento, in this case. And what happened was that the client had requested a feature, like turning, in this case, previews for products, okay? And he said, oh yeah, we have it, it's included. We just turn on the switch and that's it. Well, it happened that the client came out with this letter, or pseudo email, because it's kind of fake, but it happens. Oh yeah, blah, blah, but I also wanted to be able to turn this feature off or not for products. So now we are in a mess because we trusted our framework with our hearts, and now we have no way to tweak it or to make sure that the functionality remains as we try to add this new feature, because it's a new feature. So another talk on this same Symfony Live conference was from my friend Jacob Salas. And what he was explaining with this graph here is that when we design our, our systems, we add feature after feature. Okay, when suppose we come up with a new project, someone asks a new project, so we implement all of the feature sets, and that's the heap there. But sometimes we don't care about internal quality. And we say, okay, yeah, let's do it, let's get it done, that's it. We're wrong. We need to care about internal quality, because later down the road, someone is going to ask us, oh, yeah, please add this feature A or B. And it's going to get harder and harder to implement or plug these features into our system. That is a problem. So with two sides, we saw before, we trust too much our frameworks, and now we need to see actually the internal quality, because there is external quality also. But we want like the green curve here, where the rate of features added to our system, it becomes the same amount of effort, or even it gets easier because our model matures. So we want like a steady pace for adding features. Okay, so we need a domain expert, because the domain, remember, is the thing that we are moving in. What is BDD? Anyone familiar with BDD? Behavioral Driven Development. TDD, if you're familiar with TDD, Behavioral Driven Development, should be, you should sound very familiar, and you should treat it almost as the same. Now, anyone familiar with tools like BHAT or PHPSpec? Basically, to summarize, if you're not familiar with the tools, you use these tools to enforce this test-first approach. They help you to basically write a test, describe a behavior, and then implement the behavior, your objects, or implement your system. So you plug a feature, and there's this, if you write it on Gherkin, a specific language for that, human readable language, then you start implementing from there. So you want a good set of tools. Anyone familiar with domain-driven design? We've been talking about without knowing what it is. Basically, domain-driven design is, well, you're in this environment of your work or your expertise. If the company is about making cookies, then the domain is how you make cookies more effectively, etc. And all the business processes that entail. So DDD, some people say, okay, yes, for big projects, big, large, big projects. But in reality, who knows how big is going to be your project? Especially in my case, I see it in this way. Maybe I'm wrong. You can correct me. But when you start a project and you don't know, and you're the business owner at the same time, say you're a startup. Yes, some people say, okay, yeah, because it's a startup, I'm going to run and I'm going to just, code monkey everything and that's it. No. Well, you think long term. You don't raise a startup just for a couple of months. Okay, you want to see the long term. So DDD, you don't know, so use it. And you will say, well, show me how. How do you see this code or these methodologies implemented in PHP? DDD is nothing new. BDD is nothing new. Test-driven development is nothing new. I'm not here to talk, well, saying that these things are new, but let's combine BDD with DDD. Domain-driven design with these sets of tools that are going to help you achieve a good modeling. Okay, so suppose, okay, last time I really wanted, I went to this conference in Spain, Madrid, the Symfony, and I really wanted to take this certification exam for Symfony developers. I didn't end up taking it. And I was with this, I need to, so I sat down at my place at home, And I say, why don't just write this system? Let's just make certification exam social. What about that? So it will not cost anything. Or the money will be different, it will come different in a different way. Because it's so expensive. Okay, yeah. So let's build this. So imagine you have a site and let's test, let's put in the database some exams and some questions. You know exams, right? We need a professor to maybe tell us, qualified examiner, someone, maybe if we make really, really complex system. But in reality, if there's no, you cannot find someone, just become one, right? Just become, who hasn't gone to a university or has ever been graded on an exam, Okay, so again, the spec first approach. There's your feature, sorry, I was scoring. So this is a Gherkin feature. You write this, basically a student taking exams and responding question after question, and at the end it gets graded, okay? So it's a given and when, then. That's your specification. So the process that I'm proposing is the whirlpool, the iterative process. You have that feature down. Let's use the tool, the BDD scenario, in this case, BHAT, and let's write a class that implements the methods using BHAT. BHAT bases its functioning on regular expressions, so you match the steps to a class that has methods, a basic class, any class. It's called a context class. That helps you, it's DSL, it's called DSL because it helps you to define or explore in the main language. So in this case, yes, you have exams, you hear well, you have attempts because a student attempts an exam, you have exam reports, you start seeing this third layer, and here we see the intervention of DDD, domain-driven design. Domain-driven design is a discipline that has patterns. So in these patterns has building blocks. And some of these building blocks are repository, entity, value objects, services, interactors, which are the use cases of your system that you're trying to implement, ports, views, or DTOs. DTOs is data transfer objects, which basically is a structured object, which contains data. And then you use what's called the PHPSpec2, which is basically helps you map, okay, yes, you have the idea of these building blocks, but now let's take your class, your big class, which you have mapped with regular expressions to human-readable Gherkin language, which is your first specification that we saw at the beginning, and let's basically decouple everything and create those components. So if there is a repository building block, let's create an exam repository. So it's like a shelf, you have exams stored there, and if you want one, you just pull it out, like pulling a book out of a shelf. And so you can have also attempt repositories. Notice these are not doctrine, for those familiar with doctrine, or they are not persistence specific. So they are not tied, they are not coupled with doctrine or any other layer, persistent layer. They are just repositories as I am describing them. Then you do the same with the exam, attempt, question. So an attempt is an object because it stores the answers that the student writes for the exam, and the exam has questions, and the question has options. And you have services that, in this case, you want to grade something or some attempt, then you have a grader service. This thin layer is part of the model. You have a converter to convert views, and then you have the use cases. Notice that show all exams name. That is basically you want to display all of the exams that are available. Say you have an exam certification for Twig, exam certification for Symfony, Zen Framework, Laravel, whatever, why not? And then you have these coming back and forth. Yes, as you, let's say now you want a feature set, you meet with your expert, the professor, yes, now I want to be able to create a use case for a professor to build the exams, okay? So you write that and you pump it into your flow. That's gonna break things, yes, it's gonna break things as you see, but you have all of this scaffolding to help you repair those tests, bring them back to life, green, and learn about the model, refactor the model. That's not the same as we call refactoring in PHP, like refactor a class, but it's refactoring the whole model. The whole model, how you have modeled your design, your domain. And so you learn, you refactor the behavior. It's a learning process. This slide is coming from that side on the foot, and it's basically the whirlpool. You code prop, then you write, tell a story, a new scenario, you challenge your current model, you refactor, and then you basically propose a new model. You refactor by proposing a new model and challenging it. So it's a learning process. You don't know, I didn't know anything about how am I going to create this site about grading at the beginning. Now I know a little bit more. And so you go learning more and more and more. Okay, so how does this look like in your PHP folder structure? Don't think about any framework at all. Let's just think about classes, PHP classes, and let's see why do we need this. The folder structure is very important because it conveys the principle of inversion, which we saw earlier in the talk by Benjamin. And we also make the dependencies explicit. We convey more. And we also have a separation between what's your core domain and what is implementation detail, which in this case is infrastructure. And then thereby you start separating, okay, this behavior is modeled in this way better when I am, say, doing grading of exams, and this behavior, this modeling works better when a student is taking an exam. So you separate bounded context. Those are bound by the lines that you draw, splitting your design. This is an example. I'm going to go fast here. So these are the features, the models, how you see the attempts, exams and options and questions, how I order them to place them under folders. The domain contains models, ports, also contains services layer, as we saw it, for convert and grade. Notice the ending is a spec. That means I'm describing with these classes the behavior. I'm not implementing them. The tool is going to help, the tool set, the tool chain is going to help me implement them and also repair all the tests that are broken. There is a support class, which I use at the beginning, upfront, to basically even spec the class, context class that maps the human readable Gherkin features into methods that I'm exploring, okay? And the use cases. When we talk about use cases, we talk about, for instance, grading an attempt, and we're going to spec it, and that's why the title of the talk, the original title of the talk was Specing Interactors with PHPSpec and with YOLO. YOLO is a framework. I'm going to talk a little bit about that later. And so you now see, okay, that was my core domain, and now I'm going to have a folder, okay, in the same project that's called infrastructure, and in there I'm going to store things that are specific to the implementation details. I say implementation details because a detail is something that you shouldn't care too much about, right? If it's a detail, it's a small detail, sometimes we say. So the importance of the core domain model, as you're modeling, it must be paramount, so must be supreme. Then it comes the implementation. They say, okay, your client wants you to use like the command line, or you just want to test something in the command line. So Silex with C is a framework based on Silex with S, which is a Symfony-related micro framework. And in here, you can see that I write a specific glue logic that ties my core domain logic into this framework. That's the folder Silex there. If I want to do the same, maybe, or for just having a persistent layer, in this case, I'm going to be specific, say, okay, with the team says, let's switch to Cassandra for databases, or let's switch to CouchDB or other. Then we have a folder for specific, say, if I'm using Doctrine, I write an ORM, exam repository implementation of my actual other class that is totally decoupled. It doesn't know anything about Doctrine, it's like a chef. But this one has knowledge of Doctrine, and it's totally coupled. I could write in-memory repositories for making my tests fast. So you see, that is one side benefit of modeling in this way or developing in this way. You don't write your tests and run them slow. You run them super fast because these in-memory repositories allow you to do that, because they are basically arrays, and you are not really accessing any database at all. And so you can write a PDO, and then, hey, let's integrate this with Symfony. Write a bundle. Yeah, let's define the services, and you just write that thing later, and then your core domain is coupled or is integrated with Symfony if you want. Okay, this, Symfony. Now YOLO. YOLO is a joke. It's an academic framework, and it was presented by Igor Whittler, who wrote it. And it's basically a Symfony without the mess of some of the bundles that create more integration or make more decisions for you. But it does use the DIC component that makes it powerful. So it doesn't have too many decisions made, and it's very academic. You can actually learn a lot from using YOLO. So when someone asks you, or your client does, okay, what are your use cases? What this software is doing? Show me. You will actually point him to the use case folder in which you will write the behavior. Okay, this system now does that. It grades an attempt by a student. That's it. You're basically showing straight right out of the bat what your system is doing, your core domain logic. This presentation, here a slide from Igor Whittler, I'm going to use to explain more about interactors. What are use cases? So basically in use cases, you have your entities. These are not Symfony entities or doctrine entities. These are entities at the domain-driven design level. So they don't know anything about persistence or any other. And then you have a claw, a mechanic claw, which basically takes entities, does something in a box with it, and you get they get activated by a request, and you do something, you produce a product, and then you return something. That's the response. But all of this is separated with this boundary. This wall that you see, the lines, Uncle Bob does say in some of his talks, the art of designing software is basically drawing lines. And in this case, we've drawn a line that is a boundary. The inner part don't know anything about the outer part. Okay, that's the idea, decoupling. And in this case, we use it, okay, this is an interactor. Interactor is a box where something happens, and so you use some services, and you produce something. And those are the use cases. So when I am grading, basically I take an attempt object entity, an exam, and I produce the number 20 or 100 or whatever, or A, and I'm going to return that over a comport. So talking about that process of refactoring our domain, we go from domain to domain, conveying intention in our classes in the way we program, we design, and we become more expressive with how we write our methods, our classes, our services. The names, even the names or the, how do you say, the scope. We make explicit what it needs to be explicit. And, okay, so another tool that we can use to basically refactor from the main is called event storming. There are systems, you could have a very complex business domain in which basically is interactions of subsystems, and that they fire events or notices to other systems, and you want them to do that because otherwise it'll be all messed up, all mixed, all coupled. But then in this session, it's like an agile session, like people stand up, let's look at the wall, put up post-its there, let's put post-its for all of those events, and then let's start dividing, drawing lines. Let's create bounded context. And so it's a very interactive, interesting way of doing. And here I show two terminals, okay? One of the things that is a little bit funny, when someone does TDD, you don't hit the return like, okay, test it, test it, test it. You want actually, as you write the code, you want some runner to be running the test over and over and detecting the changes that you do. And this is on the right side is the PHP spec. So all of my PHP specs are passing in this case. There is an error for one of the feature steps, but all of those are green. So I'm doing good, but no, I have to check back. So it's a learning process. Okay, show me what you did. Okay, I've been talking about. So who knows Composer? There is a talk right now in Composer. basically this is composed. You tell it what repository to use on GitHub. This is on GitHub. So the core library that I created for the exam, it was exam simulator, and that is on GitHub in a separate repository. That's not coupled with implementation details. And now I'm going to use a YOLO, which is the framework. So I specify the dependency, and I tell it, hey, pull also my library, my core library, so that they are not together in the same repository. They shouldn't. And here is running from the console. And it shows the 2 exams that there are in the database. I'm going to show, okay. Let me do the demo now. If I can. Okay, so you can see here the library is under vendors folder, which is where the composer places the dependencies. The libraries here, you can see the features written for them, the specs, being analogous in parallel to what is written here on the source, the models, the classes, the use cases. And now, because this is a totally independent library from the framework or whatever other bench you're using, in this case Silex, you can see there is no other folder outside dependencies and just this console, which is basically using the runner, we wrote on under the console folder in Silex infrastructure of the simulator, and then we just run it. So that is what we saw. What we saw there. It's with Symfony, but you can see because that's changed on the database. So you can see the demo table, the demo database with exam table, and it's got the Symfony exam part 1, part 2. And it stores the questions also that we store them, but in terms of blobs, because this is an aggregate, the exam is. And so and that's coming from the BDD field, the terminology for aggregate roots and that. There are 2 books where I'm drawing and all of the blog posts about DDD, you can go and Google them. One book is from Evans, don't remember the other guy's name. We can talk about that afterwards. Okay, and now let's show these works for Symfony and YOLO, because those are not on the console, they're on the browser, right? So let's first do Symfony. So just to show, this is the Symfony application. Okay, and it has a root. So that's listing the 2 exams on the database using the same domain logic. So I'm doing the same as I did in Silex, plugging the dependency, just plugging some glue, connecting, that's it. Same thing. Now let's do it for YOLO. YOLO is a little bit different, so it doesn't have specific views or controller resolvers. It's a little bit tricky, their setup, so it actually streamlines everything into a string. It's got a class that stringify the result, the response. So it's not like a nice HTML list, but it's just like string. And then okay, so what I did here, is basically I wrote what is the commonality of YOLO and Symfony and Zen framework and other frameworks like Laravel they do use a class that was popularized by Symfony, which is the HTTP kernel interface. And this class basically is like the server world, how it works. Okay, so I get a request, I have the kernel, I have a method, single method in the kernel that is called handle. So it handles the request, and it returns a response, and it sends it back. That's the whole HTTP layer abstracted, how it works. So again, you have a handle method on your kernel, you get a request, or you might get a request like, $, underscore, get, or whatever, but everything is abstracted. So you call request, create globals, create from globals, and that creates you an object request containing all of that. That request object is, you pass it to the handle method of the kernel, and then you return a response object, and then you send it back. So the interface for this app kernel, or is called HTTP kernel interface. This HTTP kernel is shared. So what does it mean? It means that now we can have middlewares, like in Java. Middlewares, and that's I refer that to a page called stackphp.com. You can find everything about that. But basically, in this case, I have what I've done is the following. I basically say, okay, if I receive a request on this with a Symfony /Symfony root, or then I will tell Symfony kernel, hey, handle it. If I now receive a YOLO 2 root, then I call YOLO kernel and say handle it. So now I have one application with two different kernels, or kernels, and so now it's running, as you can see here. Oh, corriente. So now I have YOLO and Symfony in the same thing, in the same. This is just extra fancy stuff to just show off the Stack PHP project, which is led by Igor Widler and Bo Simensing and others. And so, okay, I guess that's it. But everything. So going back to what we've seen, what we are trying to, the purpose of the talk is to make you change your mind in terms of how you design, how you program. You don't marry a framework. You want to solve problems. So therefore, you break free from all of your frameworks, from all of your lovers, or all of our lovers, and then we focus on solving the problem. And then now let's put the negatives. Let's play the devil's advocate. Okay, yeah, you've done that, but what? Yeah? I need to do this quick. But there is a blog post by Uncle Bob also about being fast with the test-driven development approach that answers that. So I can reference that. But basically is that when you write your test, you actually don't go slower. And it's like a misconception. Another excuse or case against this would be, okay, my system is too simple. But again, we say, okay, but I don't know how big it's going to be. Usually, if you want to play big, I can remember a guy who, Chris Will Smith says sometimes, go big or go home. Basically, you want, especially if you care about your project, you want to try at least the BDD or apply some certain scaffolding with these tools. Okay, so that has been most of what I want to present. Now, is there any questions that I will be glad to answer?